So we've been looking at the dates. Now, remember I said that the cast stone at the bottom, can anybody remember what age that has been dated at? 109 million years. The layer at the top, can anybody remember what that was dated
99.
to? 99 million years, very good. So, can anybody tell me, according to those dates, how long did it take to lay these cliffs down? 109 at the bottom, 99 at the top.
200.
What is
218?
109 at the bottom, 99 at the top? What's 109 minus 99? 10 million, yes. According to those dates, it took 10 million years to lay these cliffs down. Now that sounds fine. Remember I was talking about the mud at the top? Okay, we can see that, we can watch that happening. And it probably would take about 10 million years to lay down that layer of mud as thick as these cliffs here. It's really, really slow, okay? But there's something in these cliffs that the mud does not have. And we've been digging them up all afternoon, which is fossils, right? And remember we've been talking about how those fossils are pointing the same way. We've been talking about how you can show those fossils have been formed quickly because they were all closed, they've been buried alive. In fact, just simply by the fact that there are fossils there means that it had to be formed very quickly. Because if you take a long time to create your fossils, to bury your creature and to fossilise it, your creature will get destroyed long before you even have a chance to turn it into a fossil. Okay? It has to happen quickly. It's got nothing to do with time, but everything to do with the process. But let's just humour these dates for the minute, okay? A 10 million time span to lay down these cliffs according to what these rocks are dated at. What is the height of these cliffs? Well, you will notice that the cliffs have been getting taller as we go along, okay? That's because these cliffs have been tilted. The thickness of the deposit is the same, it just goes down a lot deeper into the sand that direction, okay? So if you go by that direction, which is where you can see the bottom of the formation, it's about 20 metres tall, 20 metres thick, okay? Which is not a huge formation given some of it. In Norfolk, sometimes the chalk goes down almost 1,000 metres, okay? So it's ridiculous, okay? But it's about 20 metres thick at the tallest point here. 20 metres is the same as 20,000 millimetres, yeah? It's just a different way of expressing it, all right? So, according to the dates, it took 10 million years to lay down 20,000 millimetres of sediment. That all understandable, yeah? That's according to the dates. Now we do a very simple maths equation, okay? We take the height of the cliff, the height of the deposit, 20,000 millimetres, we divide it by the time it supposedly took to lay this deposit down, which is 10 million. 20,000 divided by 10 million equals 0.0002. That is millimetres. In other words, if those dates are accurate, every single year only 0.002 millimetres of sediment was being laid down.
Or 1 millimetre every 500.
1 millimetre every 500 years, exactly. Okay? You can barely put your fingers a millimetre close together. You certainly can't put your fingers 0.002 millimetres close together. Okay? Now ask yourself this question. If those rates of formation were accurate, remember, those rates of formation come from only two pieces of data. One of them is the supposed age of the cliffs, the other one is the height of the cliffs. One of those pieces of data is provable, testable and repeatable, and if you don't believe me, you can jump off the top of it and see what happens, okay? You can prove the height of the cliffs. You cannot prove the age of the rocks. We have put two pieces of data into a maths equation. Maths is absolute. You cannot argue with it, it is a basic equation. You have got a ludicrous result. Ask yourself this, if those rates of formation and those dates were accurate, would you ever get a fossil? No, it would be destroyed long before you'd have a chance. Just try laying down one of these fossils. Now, do you remember that little brachiopods that we found earlier? Yeah. Right? It would have taken about 18,000 years to bury that. right? If you lay a shell around for 18,000 years, it's going to be destroyed much, much longer, long time before it's ever going to be buried, let alone fossilised, okay?
Even plastic though.
Even plastic won't last that long, right? It's going to be destroyed. But let's go one step further. If those dates were accurate and that rate of formation was accurate, would you ever get a deposit? Because you see, in order to get a deposit in the first place, your rates of deposition have to outweigh your rates of erosion. Remember, I was telling you about that lady who I met who said when I was a little girl, she was in her 80s, when I was a little girl, these cliffs used to be out there. They've eroded about 30 metres in the last 60 to 70 years. Right? That rate of erosion is far, far, far greater than 0.002 millimetres a year. Your rate of deposition has to outweigh your rate of formation, otherwise you'd never get a deposit in the first place. So if those dates were accurate and that rate of formation was accurate, these should not be here. And yet they are here. And yet they are crammed full of fossils. In fact, the cliffs themselves are essentially fossils. The chalk, the limestone, is made up of tiny little seashells called Biblicaltours, which are from plankton. They're tiny little bits of seashells. So essentially the entire cliff is a fossil, or a mixture of fossils, right? Something does not add up. There's one more piece to the puzzle. Norfolk is quite famous for chalk. Like I said, the majority of it is chalk. It goes down 1,000 metres in some places. But of course, there's plenty of other places where chalk is famous for, the White Cliffs of Dover being one of them. The great big chalk cliffs of Dorset being another one. There's chalk on the Isle of Wight. There's chalk in Yorkshire. There's chalk in Wales. There's chalk in Scotland. Chalk goes all over the UK. But it's not just in the UK. It also goes west to Ireland. It goes even further west to North America. It goes southwest, if you like, to South America. It turns up on the west coast of Africa. Then it starts going east. Normandy, very famous for chalk, goes through France, goes through Europe, goes through Asia, and it turns up on the west coast of Australia. It covers a huge part of the Earth's surface, and it is all provably the same chalk, because it has the same fossils in it, and it all sits on the same bed of sandstone, just like here at Hunstanton. It's all the same chalk. It's all extremely thick. It all covers the majority of the world. It was all provably laid down very quickly, because you can use that equation, that equation that I did, right, work out how long it supposedly took the cliffs to form, and divide it by the height of the cliffs. You can do that literally anywhere on the planet. Okay, you can do it literally anywhere on the globe. You consistently get stupid results every single time. Okay, you can do it everywhere. It happens with the chalk everywhere. Something doesn't add up. You've got a global deposit that has been laid down underwater, all at the same time, very quickly. It's starting to begin to sound a bit like a worldwide flood. Okay, there's another little piece that we can talk about. Do you remember the old school experiment of you get a jar, you pour water in it, you pour stones in it, you pour mud in it, you pour sand in it, you put the lid on, you shake it up, and you watch all the layers settle. Yeah? It's a fantastic experiment. It would be even better if the world was a glass of water, but it's not. The reality is, the only way that you can move sediments in the real world is by water moving sideways. Think of streams, think of rivers, think of layers being moved along. There is nowhere on Earth where you have a massive area of water with all the sediment just sitting there waiting to settle. In order to get sediment, you need to have water moving sideways. Okay? Now, there was a set of experiments done by Creation Research, which I have the privilege of being involved in Australia. We're replicating that in the UK now as well. Basically what we did, they took a flume and they blasted water through it, going sideways. And they poured sediment into it, different types of sediment as well. And they watched as that water carried it sideways and laid it down going sideways, and this was the result. These are not graphics or anything, these are actual pictures of the experiments that we did. Can you see all the layers? Can you see how the layers have been laid down going sideways? Can you see how the layers, particularly here on the top bit, can you see how you have different bands of different layers?
Yeah.
Different density of sediment being laid down at different times, okay? Being laid down in different places rather, at the same time, moving sideways. That is exactly what we have here. Highest density is at the bottom, very, very dense stuff at the bottom, okay? Sandstone, basically just bits of quartz, bits of flint, very heavy, big boulders. Then you've got the red chalk, which is the same as the grey chalk, except for one thing, it has iron in it. Iron is very heavy, it's dense, it sinks fast. Then you've got the lighter stuff at the top. You have got different currents in play here, moving this sediment along. Remember, the fossils are all pointing in the same direction. These have been moved by currents at the same time depositing it. Look at the cast stone at the bottom. Can you see the current marks in it? The circular motions as it goes through. These have been moving sideways. These are being deposited the same time, very quickly, by different currents, dumping them one on top of the other. Now that rate of formation that I was speaking about a minute ago, the 0.002 millimetres per year, okay, it's obviously ludicrous by any standard, but you find ammonites here, and we may find some ammonites as we go up, okay? The ammonites can be sometimes up to about 30 to 40 centimetres thick. Think how long it would have taken just to bury one of those, if those dates aren't correct. And the reality is, the dates have got nothing to do with science, the dates have got everything to do with one man, called Charles Lyell. He introduced the idea that the Earth was very old. He introduced a process called uniformitarianism. He promoted the idea that layers laid down on the bottom first and then pulled their way up, okay? How did he get to this conclusion? Did he do years of scientific research? Did he do lots of testing? No. Unfortunately for him, his sister-in-law published several letters of his after he died. In there he said, my theory of uniformitarianism, which is a big long word basically to mean everything takes a very long time, my only aim in promoting this is to quote-unquote free science from the Bible, free science from Moses. In other words, he was a lawyer as well. That should have been a clue. He was a Scottish lawyer. He wasn't an academic. He wasn't trained in geology or natural science. He was a lawyer by trade. He didn't like the idea of God. He blatantly stated it. He didn't like the idea of judgment. He didn't like the idea that he was accountable to anybody. At that time, the majority of the scientists were also theologians. They believed that Noah's flood is what had caused most of the geology around here, and they saw evidence of that in the rocks all around them. Of course, if you've got a global flood, you have to have a cause for it. The Bible explicitly states that the cause of the global flood was God's judgment on the wickedness of man. That means that there's a God, and that means he has the right to judge. And not only does he have the right to judge, it also means that he does judge. We saw that in Noah's flood, and he's also promised us he's going to judge again. Right? However, you teach that the earth is extremely old, you teach that everything can happen given enough time, despite the evidence that blatantly says that it can't, because you'd never get a fossil and you'd certainly never get any living things. It's got nothing to do with time and everything to do with the process. But if you convince people of that and you manage to promote that, all of a sudden you've done away with the need for a God, you've done away with the need for... think about Moses. He said, I want to free the signs from Moses. What did Moses write? Because it wasn't just Genesis. It wasn't just the creation. It wasn't just the fall of mankind. It was also the law of God. You want to get rid of creation, you get rid of the fall, you get rid of the judgment, you get rid of the law for God, you get rid of any need of God in the first place. However, just because you believe something, just because a lot of people believe something, doesn't make it true. I'm a Christian here, I know most of you are all Christians here, and I hope most of you believe in Jesus Christ as your Lord and Saviour, because he has promised us that he is coming back to judge again. But just as he provided a way to escape the oncoming judgment in Noah's day, i.e. the ark, he has provided a way for us to escape the oncoming judgment that will come again one day, and that way is Jesus Christ. The question is, make sure that you actually listen to God this time, and don't mock him, and don't refuse to get on the ark. Actually accept him as your Lord and Saviour. But it puts it into some really big perspective. And that, by the way, I said the most important thing. I suppose the most important thing is the gospel, obviously, but the process by which you can do that, that simple maths equation, right, is applicable anywhere. The idea is there. This is why we need field trips, because you can physically come and dig up the evidence for yourselves. You can physically see the fossils for yourselves. You can do the research yourself, and that speaks volumes to people. Okay.